Tonight I wanted to show you a simple example of introduction to truth statements and a couple of simple examples of truth tables. In this particular problem, P is defined as true and Q is defined as false. And we're going to answer the following 4 questions. If P is true and Q is false, then P or Q is what? Well, the or statement means at least one has to be true for the statement to be true. It could be one or the other or both. Since P is true, then the statement P or Q is also true. Now, this little squiggle here is the negation sign. So if P is true, then not P, we read that not P, is the opposite of true, which is false. Now we're going to do a simple truth table here. We have a statement, P and not Q. Now P is true, we put our T down here, and Q is false, so not Q is true. Now with the and statement, both P and Q have to be true in order for that to be true. In this case, both of these have to be true. In this case, they both are. So P and not Q, given that P is true and Q is false, P and not Q is true. One last example. This one's a little bit longer. This is the negation of not P or Q. And notice the parentheses here. And the parentheses here have the same effect as they do in algebra. In other words, we work inside the parentheses first. So we're going to do all this inside part first, then we're going to take the negation of it out here. Remember, P is true, Q is false. So what do we do next? We'll take the negation of P. If P is true, the negation of P is false. And then we want to do not P, or the negation of P, or Q. Well, we have false or false. False or false is false, because remember with the or, at least one has to be true. And finally, we take the negation of the whole statement. And the result of what's inside the parentheses is right here. And now we're taking the negation of that. So the negation of false is true. So this is your final evaluation of the truth statement, not P or Q is true.